correlation does not imply causation. So, for example, I think I've talked about this before. I could see a correlation between the number of hours a student spends in the Math Study Center and their math grade. There's a correlation, and it's positive, meaning the more there, the higher the grade. Does that mean that being in the Math Study Center actually causes their grade to go up? No. What else could it mean? Good students do everything they need to do, so they're going to do a good job anyway. So that actually, their being a good student, making good grades, actually influences the number of hours they spend in the Math Study Center. It's like the total opposite. Are you guys semi with me? So often in the news, this is what I really want you to get away from this. People talk about correlations as if they know what causes what. In fact, they're very often, since there's so many other variables that could cause an effect, we don't know what it is. So this is a true fact. If teacher salaries increase, the sale of liquor also increases. That is true. You can find that to be funny. You can go, well, that, why not? Teachers seem like they might drink. But the truth is, if teacher salaries goes up, what more than likely is true? Everybody's salary probably went up some, or a decent chunk of the population's salary probably went up too, right? Or at least, government people. You guys see, so there's a third thing behind the scenes that's causing that relationship that I see. Yes?
Like hypothetically, there's a correlation with that causation?
No. That would not. Which is, you would think it would, but even then, I don't know which variable is causing the other one, and I don't know if there are other variables not in my study that are affecting both things also. So, for example, the Mediterranean diet. You guys, have you ever heard of this? I mean, this was a big thing a while back in the olive oil. Everybody thought, if I use olive oil, I'll lose weight, because look, they use olive oil. All right, that is really silly. You could find a correlation between people there that use olive oil and their weight versus, you could find a correlation, but there are other things that cause changes in weight. In Europe, more people walk, for example, right? They have smaller towns that are built based on being able to get everywhere. So they walk to the store, they walk to school, they walk all over the damn place, right? That might affect that, right? And maybe. So can I definitely say? So don't answer this question as no, and don't answer this question as yes. Answer this question with, we don't know. That's the correct answer. Don't say no, because I'm like, how do you know? Don't say yes, because then I'll be, how do you know? So the right answer to that kind of question is, we cannot tell from what we've done. We have definitely established there's a relationship between the two. But we can't tell which one affects the other. Or if there's some other variables that we didn't think of that are affecting both. Maybe. Now, the part F I want to add. Do I trust this line to make predictions? Was our R pretty good? Yes, so therefore I'm going to trust this line. It's close to the data. So what if nobody studied 19 hours, right? Nobody studied 19 hours. So how many mistakes would I expect them to make? So if I study 19 hours, how many mistakes do I expect to make? If only I had like an equation where I could put 19 in and have something come out. Well, what is true about this equation? What does x represent?
Number of hours.
Yeah, x is the number of hours studied. And I want 19 hours of studying, so I'm going to put a 19 in here. So now listen. Before, what was our best guess for any group of data? If I have a group of grades, what's my best guess for anyone's grade? We know this. It's also called the point estimate. And I told you another name for that was best guess. If I have a group of grades, What's my best guess for anybody's actual grade? You can do this. If I have a group of data, grades for everybody, what's my best guess for your grade? It would be the average of those, right? In fact, what is another name for average? Expected value. Are you guys with me? All right. So, but if I have a study like this, I've improved on my guess. That equation is now an improved guess. So the worse my R is, the closer it is to 0, the less I trust that line. And if I can't trust the line at all, I just use the average. That's my best guess for everybody then. So is my guess better than just the average now? Yes. Because I have this line we calculated. If I put a 19 in, we can calculate what this is going to be. I would say, what's the negative ratio? I'd say like 3. I'm trying to do that in my head. Let's see what it is. .6. So that's my best guess for the number of mistakes somebody who studied for 19 hours will make. Or the average of everybody who studied for 19 hours. That actually is closer to what this represents. Because how many people studied 11 hours? 3 people. And they all made different grades. Why does that make sense? Because there are other variables that affect what grade they're going to make. How many beers did they drink the night before? Right, and so forth. Right, this is mistakes made, but you know that's related to the grade. Okay. Oh, and let me just show you this. Here's a slight shortcut to what we just did. The calculator has this line in it. It's all about calculating shit. So if I hit second trace to go to calc, I want to calculate something on my line, value, if I go to value, put in 19, there's my 4.672. There it is. Whoa, it's one step too much. You guys with me? You can't make predictions, and here's the other thing about these predictions. It will not work for anything that is outside of my data, which kind of makes sense. If I track a fish growing, the length of some fish, and I track it for, I'm not a biologist, the first few weeks of his life or whatever, maybe it'll be like this. And then if I use this predict, well, in a year, how big is it going to be? It's going to be able to swallow Manhattan. Oh, this could be, let's kill that fish. Oh my God. And of course, what's going to happen soon after this is going to level off. So that's why, if you're going to use the equation of the line of best fit, you can only use it within the data it was created with. I can't use it on this problem. I can't use it for less than 2 hour study, or more than 24-hour study. I have to live within there. Outside of there, who knows? It could go crazy outside of there. One more thing I want to show you before I move on. Just to satiate some interest. 2 things I want to show you. Let's try to do this real quick. You don't have to worry about linear regression in this course. But if I try to do, let's try to do quadratic right now. Let me see if this makes sense to you. If I use quadratic regression instead, let's see what it does. You guys remember quadratic formula? You've heard of it. I'm not going to make you state it. Come up here and say it. No. So now I get ax squared plus bx plus c, and it gives me those values for those coefficients. Now r squared here is 0.86. Let's go back real quick. If I go back, 0.86 r for that, right? If we go back to my linear one,